Hey guys, so what should business owners know about real AI expertise? That's what we're gonna be seeing in this video. And the reason I decided to make this video is that I've seen a lot of business owners that are super confused about what they should expect from an AI expert. And what should those people know actually? What are they trained to do? And just to, clarify things up, basically educating business owners about what those AI experts know, and also telling you a little bit more about the big picture. So let's get started. So as you probably know, if you have seen some of my previous videos, I have done a Master of Science in AI from 2019 up to 2021, and I did that after a Bachelor of Science in Computer Science. And I basically was trained on AI, and we did some very complex projects, both for the industry and academia. And I will tell you more about that so that, you will have a better idea about the real AI skills of AI experts. So basically, I have decided to group together the courses that I have studied into multiple subjects so that it will be more clear for you the objectives of those courses, basically. So the first one is about delivering real-world projects from start to finish. And the courses that are relevant for this are first the research projects during 2 years. So each year we had to do a research project, and each time it was for a different topic. So for example, the second one was super interesting because it was about mind reading. So developing an AI algorithm that was super complex. Actually, this resulted into a paper that I published here, as you can see. And basically, we had to really create AI models from scratch, train them, evaluate them, and then make them super accurate. And as you can see here, the AI models were analyzing brain data to try to classify which type of activity those persons were doing, basically. I also did my internship in a French company. We also created advanced AI models, actually adapting the transformer architecture into a very niche problem, and this also resulted in a paper that you can see here. So it was about a task called audio source separation. So imagine you have like a file of a song, for example a Michael Jackson song, and we want the AI to analyze this audio data and then to output two files. One file that contains only Michael Jackson singing, only the artist singing, and the other file containing only the melody, the instruments, and the rest of the song. So it was a quite challenging problem, but it was very interesting, and actually the transformer architecture helped us train the model in a faster way, but also to make it more quick to use, during inference. This is called inference in AI. And for the master's thesis, I also did a very interesting project where I had to forecast the wind speed. And this is actually a very interesting topic because we could apply those algorithms to do trading, to do algorithmic trading, and to trade some financial instruments, but this could be the subject of another video. But it was very, very interesting. As you can see here, this is a graph of the real data, so what was actually the wind speed, and the prediction from the algorithm that I trained. So as you can see, it is very close, but there are multiple techniques to make it even more accurate. So very interesting, but very practical most of the time. So what you need to know from this group of courses is that the business outcome was mainly about creating intellectual property. And this is extremely important for businesses out there who want to have a competitive advantage. And I will tell you more about that in the next part of the video. So it was about hands-on projects where theory was applied to real problems. And we had to go through all the cycle of innovation, basically coming up with the problem, then designing a solution, building the AI, validating the results, and then writing the report. Then the second group of courses was about extracting knowledge from messy data. This concerns pretty much all companies, because all companies, they have a lot of messy data. Some PDFs, some text files, some audio, some transcripts that are even not well written, some annotations of contracts, and so on. So how do we organize this messy data, right? This is a very interesting question, and the solution sometimes is worth a lot of money. Like Google, the reason they decided to organize internet data, it's because it's worth billions of dollars, right? So yeah, this is something that is extremely relevant to all companies around the world. And the courses that were touching on this subject were called information retrieval and text mining. So information retrieval might ring a bell for you, but nowadays the term RAG is extremely popular. It stands for Retrieval Augmented Generation, and it's basically about retrieving specific information from custom data using LLMs. And even at that time, LLMs didn't exist, but we still had to do retrieval, because retrieval of information is something that is super old subject, and we had to do, for example, topic extraction or summarization. All those topics nowadays LLMs can do them, but back in the days we could also create like smaller scale models to do exactly that. We also studied a very interesting course called Building and Mining Knowledge Graphs. So if you have been following the RAG topic, you know that there were some RAGs called graph RAG, where you organize the data in the form of a graph, so that you can ask like a question in natural language. For example, what was our yearly revenue during the last 5 years or something like that. And then the LLM will turn that into a query that can fetch a graph database and then return the result. So yeah, we learned a lot about basically how to build those knowledge graphs, but also how to extract insights from those knowledge graphs. And the business outcome is super obvious. It's about turning unstructured or messy data like emails, PDFs, reports, tables, charts, and so on, into structured knowledge you can query. And more than structured knowledge, it's about actionable knowledge. So as I told you, we also built knowledge graphs to connect people, products, and processes inside the company. And an example could be a legal firm automatically linking related clauses across thousands of contracts, or a healthcare company connecting symptoms, treatments, and outcomes to decision support. The third group is about customizing advanced AI models. And the course that corresponded to this was Advanced Concepts in Machine Learning. And it was about basically knowing the behind the scenes, like really how those AI models work. Imagine like you are a car mechanic and you dive deep into the engine and how all the mechanics are, stitched together. So not only we did the work of a mechanic, but also the work of an engineer. So designing new architecture, think of like the transformer as an architecture, but we also had the ability of creating new architectures just out of innovation, just out of imagination. We could basically, because at the end of the day, those models are working like Legos. You have building blocks, and if you want to create a new architecture, you just need to assemble those building blocks in a different way, So yeah, it was going beyond the plug and play APIs. Obviously, right now we have a lot of APIs from Gemini, ChatGPT, and so on, and it is very easy to just consume those APIs. But what if you have data that shouldn't access those APIs because of security reasons? You're stuck, right? You need to be able to either reuse something that is local, right? Or even create a new model, because let's say that the data is not text, it's sensor data. You will never use an LLM on sensor data, right? So you need to have those skills to be able to create a new type of AI that is adapted to a very specific data set. And some examples of that could be customizing a customer churn prediction model to a company's unique history, or adapting AI to perform well when there isn't a big tech-sized data set. This one is actually quite important because, you know, when we think about AI and deep learning, we always think about like gigabytes of data or even petabytes of data, like a lot of data. But what if you're a company and you have only, I don't know, 50,000 samples, you know? You can still use AI, but of course you will not use deep learning, but you will use another type of AI that can still give you insights and still benefit your company, you know? Another group of courses is about building decision-making systems. And the courses that are relevant for this are Foundations of Agents, Multi-Agent Systems, Intelligent Search and Games, and Autonomous Robotic Systems. Those 3 courses were extremely interesting. I really enjoyed that. But yeah, in multi-agent systems, we studied very interesting stuff. At the time, there was a paper from DeepMind called AlphaStar, where basically the people of DeepMind, they trained AI agents to play StarCraft, which is a very famous game, a strategy game. And here's a small video about it. And as you can see here, those are agents that act autonomously. And they were trained to optimize a reward, which is to win the game, basically. And they need to plan actions and so on. So super complex, but still very interesting. And if you want to know more about this, the paper is called Grandmaster Level in StarCraft 2 using multi-agent reinforcement learning. So this type of machine learning is used for AI agents, you know, and it's basically to teach AI agents to make the best action to optimize its rewards, basically. It's like teaching a baby. If you want a good behavior from the baby, you want positive reinforcement, right? So that's what we are doing basically in this paper. But as you can see here by the number of people, this is a very hard task where a lot of PhD nerds will have to work together to accomplish that. So it's not about only, you know, using AI, LLMs and so on. It's about really diving into the maths, the algorithms, the charts, the plots, analyzing them, interpreting them, and so on and so forth. And then in another course, Autonomous Robotic Systems, it was more about robots and robotics and how basically can we develop the brain of robots so that they can perceive the environment in a good way and then act as they should, basically. And one of the nice algorithms that we've seen is called SLAM, which is the acronym SLAM, which stands for Simultaneous Localization and Mapping, where, you know, basically a robot tries to do mapping, as you can see here in this video, but then uses the mapping to determine its own localization, and then from his localization determine the mapping of his environment. So yeah, this is an algorithm that is widely used in any robot that you can see, whether it is from Figure AI or from Unitree or from your Roomba robots. All those algorithms are used there. And the business outcome is pretty obvious. It's about designing systems that can make decisions, negotiate, or collaborate. Like, you know, multiple AI agents are working together. And this could be applied to logistics optimization, where trucks, warehouses, and routes talk to each other to minimize costs. Or, for example, creating an AI system that can act on behalf of both the business and the customer to coordinate tasks without human management, basically. And then the last group is about teaching machines to see. The world's data is comprised of a lot of images and videos, you know, that we produce every single day by taking pictures, by recording videos, and so on. And we need a specific type of algorithms to analyze this data. We can do object detection. We can do face recognition. we can detect a type of event happening. For example, let's say we want to help a local store detect whether someone is stealing, is shoplifting, So the course was simply called computer vision. And yeah, the business outcome is also pretty obvious. It's about teaching machines to analyze and interpret images and video. And some examples are manufacturing quality control. For example, a manufacturing company is producing jeans or just clothes in general, and they want to place a camera to detect any defect. I know that a lot of manufacturing companies already have this type of technology, but maybe they want to improve the accuracy, and they want to use some new techniques like deep learning or machine learning and so on. Or for example, you have a property developer who wants to analyze satellite imagery from a county, to know which land will yield the best ROI. This is a very concrete example that could be used by property developers. Or you can have an accounting company who wants to automate the processing of invoices and will try to develop a machine learning model to analyze, those invoices and then to process the input into an Excel sheet or something like that. Okay, now we move on to the big point. As a business owner, why does it really matter to know how real expertise look like? Basically, what you need to realize is that most companies are only consumers of AI. Actually, people and companies, most of them are only consumers of AI. And basically, they hire software devs who know how to plug into OpenAI or Gemini APIs. And actually that's fine, but it means that they are limited to whatever big tech decides to release next. And as you have seen for ChatGPT 5 release, I think OpenAI missed with the GPT-4o algorithms, and a lot of people complained, hey, where is my GPT-4o? I was super happy with it, and now you replaced it with GPT-5, and all of a sudden the responses are not good and I'm not happy, So you're just being fed what the big tech is producing, which is not good, right? And as a business owner, you need to make the intentional choice about your business being either a consumer of AI or a producer of AI. And if you're a consumer of AI, it means that you will wait for new models to drop. You will have limited customization. You will not own the algorithms or the IP. And competitors, it's easy for them to copy you because they can use the same tools as you. Everybody has access to the same tool. However, if you want to decide that your company will be a producer of AI, it's all about ownership. You will create proprietary AI assets like fine-tuned models or custom datasets or optimized systems. Or you will be producing intellectual property that increases the valuation of your company. You will be building unique capabilities that competitors just cannot buy off the shelf. It's basically about combining your unique data or processes with rare and expert skills to produce unique output, assets, and IP that you will own. For example, a law firm that builds its own contract analysis model that is fine-tuned on its own case history. So as a business owner, you need to know the difference between hiring someone who just knows how to connect endpoints and webhooks and hiring someone who actually engineer AI systems. Because one keeps you dependent while the other makes you a producer with your own IP and competitive edge. Now, let me answer the big myth. Producing AI is too expensive, because maybe when I say producing AI, it means for you producing the next ChatGPT, and therefore it must cost billions of dollars, something only Microsoft or Google can do. But the reality is that you don't need billions of dollars or even millions of dollars to produce your own AI, because custom AI models come in all forms and shapes. You can take your unique data, even if it's small, and combine it with proven algorithms like XGBoost to create something that's unique to your company. And here are some examples. A retail shop predicting which products will sell best next week using past sales data, or a service business predicting which leads are more likely to convert, or a subscription-based company that builds a model to predict which client is likely going to churn, or a manufacturer predicting when machines will need maintenance. So those kind of models don't cost millions of dollars, but they create intellectual property that's yours, and that competitors cannot just buy from OpenAI. Now, some closing words. You need to know as a business owner that not all AI experts are the same. Some will consume APIs and AI, and it's fine if it achieves the desired business outcome. And others can actually produce AI. And you need to realize that producing AI doesn't require billions. It's about a small data set plus the right algorithms to create big value. And producing AI is within reach for small and medium businesses. And basically, you need to keep in mind that owning AI equals owning IP. And that's how businesses build long-term competitive advantage. So yeah, guys, that was it. I hope you enjoyed it. If this subject is interesting for you and you want to discuss it with me, feel free to book a meeting with me through the Calendly link in the description. Cheers, guys.